Hey folks, this is Dr. Sweeney. I am going to be doing some problems here from our final exam review supplemental. These are the scenario problems. And what I want you to do and I want you to focus on is my way of reasoning. Now, here's the thing. It's a way of reasoning. It's not so much all the things that you need to know. The things that you need to know, they're inside of the modules. They're also, you've been practicing them. And so, we're not going to see all the different variety of ways of dealing with things, but it's going to give you a really clear idea of the kinds of questions that you should be asking yourself and how you should be thinking about these kinds of scenario problems. I'm not going to be asking you to do a lot of calculation. Instead, I'm going to be asking you to draw conclusions based upon information, graphs or tables, and also questions that, and hypothesis testing information that you'll be given. All right, so let's take a look here. You're going to notice that it's going to actually be pretty quick for me to do it. All right, but that's because I've got a ton of experience doing this. I'm going to, be slow with you, but the fact of the matter is that you're going to have to kind of like follow along. You might have to watch it once or twice, and also to go back to your notes and review, right, what sorts of the things that I'm talking about. Okay, so let's begin. This is the first scenario on the final supplemental review. Suppose that you wanted to determine if any particular type of treatment was effective in treating depression. You take a simple random sample of 153 depressed people and assign them to 4 treatment groups: gardening, ballroom dancing, running, and Tai Chi. You then test to see if they are currently depressed after 6 months of engaging in activities. You get the following contingency table from your data. So when I look at this contingency table, what I've got here is I've got the different treatments: ballroom dancing, gardening, running, and Tai Chi. Okay, and then I've got, after the treatment, whether or not the people are depressed or if they're not depressed. Do they report depressed or not depressed? And what you'll see is first we have counts for depressed and counts for not depressed, and we have a total. And then we have for the percentage. So like 45% of the ballroom dancing group said they were depressed after ballroom dancing, and 55% said they were not depressed. Now notice this is 6 months of ballroom dancing, not one session of ballroom dancing. And that way we get something that's like a treatment. Okay. Another example, running. 7 of the people after running for 6 months reported that they were depressed. Probably weren't running for the entire time. I would be depressed after running for the entire time for 6 months. Probably just, 3 times a week. Who knows? But 7 of them said they were depressed, and 34 of them said they were not depressed. Okay, so you get 17.07% said depressed, 82.93% said they were not depressed. So we go in, we take a look at this, and we see, and I'm going to make some observations. One, if I want to ask myself, well, whether or not, right, the treatment was the treatment effective in treating depression? Okay, because that's the basic question. When I look at this, what I'm seeing is oh, well, which one was the most effective? Of the group, we could either look at the percentage that were depressed or the percentage that were not depressed. And be careful, right? Just like with any other contingency table, it's not actually the total number, it's actually the percentage, okay? Because you'll notice, like, for example, only 31 people were gardening, okay? And instead we had 41 people running. So those percentages, those totals are going to be a little bit deceptive, okay? So we look here and we say, okay, well, what percentage were depressed? Oh, 45% after ballroom dance, 54.84% after gardening, 17.07% after running, and 31.71% after Tai Chi. Okay. Well, you know what? That's interesting. I mean, it appears that the running group, we had far smaller percentage depressed. Okay, we had a far smaller percentage depressed, and so, maybe that was the most effective treatment, right? And what we're going to do is we're going to determine whether or not we have a statistically significant difference, right, between them. Like, is that difference big enough? Is the difference 54% versus 17% big enough for us to conclude, in fact, that the treatment was effective in treating depression? Okay, and that's what we're doing when we do this test. And the test that we're going to do is something called chi-squared. Right? So how we know it's chi-squared, the test will be chi-squared. And it'll be a test of independence. Or test for independence is also another way to state this. Because, and let's look at why the because. Because ballroom dancing, all of these, excuse me, not just ballroom dance, but the treatment here, ballroom dancing, gardening, running, tai chi, is a categorical variable. And we're comparing that to another categorical variable. Okay, so we've got two categorical variables. My explanatory, my treatment, is a categorical. And the depression, my response variable, is depression. And it is also a categorical variable. So I go categorical to categorical. Those are the comparisons that are being made. And so that tells me a chi-squared. Right? Now this chi-squared test for independence, that relationship, okay, is asking, are the two variables associated? We should say two categorical variables. Are those two variables associated? And the answer is, I don't know. I'm going to have to go out and test it. I'm going to have to go find chi-squared. And we're going to compare, right, okay, basically these percentages, right? It's comparison for percentages. If you remember back to when we were doing probability, you'll remember that to test independence is to figure out, is there a difference between this total probability, 35.95%, and the individual ones? And in chi-squared, what we're asking is that difference big enough for us to actually determine that we have independence? Okay? But the big idea, the big thing that we want to notice for chi-squared is we are comparing two categorical variables, right? And we're asking, are those two variables associated? Okay? Because we are comparing two categorical variables. All right. Now, like any other hypothesis test, if I know that what I'm doing is a chi-squared test for independence, I actually already know what my null and my alternative hypothesis are. Now, for the chi-squared test, we're only going to have to do this in words. Okay. There really are no symbols that we use. So what we have is, first, for our H0, we're going to assume that the two are independent. That is, that they are not associated. Okay. So notice, for chi-squared, the null hypothesis is going to be that they're independent. So what I do is I write what my variables actually are. So this would be the type of treatment and incidence of depression are not associated, or are, I like to use are independent. That is, they are not associated. You can use not associated too. HA, the type of treatment and incidence of depression are dependent. So let's just talk for a moment. What would it mean if we rejected the null hypothesis and we supported our alternative? So let's just talk about the supporting of our alternative and this phrase dependent. If what we do is we find that these two variables, say for example the treatment, these treatments over here, and incidence of depression are dependent, what we're saying is that in the presence of one of these treatments, like say for example ballroom dancing, right, we find that we are going to end up having more or less depressed people than in terms of a different treatment. So like, for example, we'll look at running because it's got the lowest incidence of depression. So let's say we say, all right, well, are these two variables dependent? And what we would say is yes, they are, or no, they are not. But let's say we said, in fact, yes, they are. We found that we rejected the null. Okay? In rejecting the null, we would state that the running group, okay, has a lower incidence of depression than the other groups. Okay? I found statistically significant evidence that this particular one, or one of the other ones, if it wasn't this particular one, actually was better at treating depression than the other treatments, right? That was my statistical evidence. I had a lower incidence of depression than the other groups, okay? Statistically speaking. That's what it means for them to be dependent. In the presence of running, it changes whether or not a person is depressed or not depressed. In the presence of Tai Chi, it changes whether or not somebody is depressed or not depressed, okay? And so that's kind of the idea that we're dealing with here, right? Was one of the treatments better, right? And when I reject the null, what I'm going to answer is yes or no, one of the treatments was better. Then we state the conclusion of the test, right? Now when I go in here, I look here, I've got my test statistic, which is actually called the chi-squared value, okay? And then I have my p-value, and my p-value is 0.0049. I go in, I'm not actually given a significance level, so we'll assume alpha equals 0.05. Okay, alpha equals 0.05. And then we have p equal to 0.0049. Okay, so what I'm going to do is I'm just going to write here, just for my own sake, I'm going to reject the null hypothesis. Why? Because p is less than alpha. Right? The probability of getting that particular sample is less than my significance level. Right? P is less than alpha. Hey, you've seen that before. You'll see that in every hypothesis test. P less than alpha. Okay? So we reject the null hypothesis, and then that tells me there is sufficient evidence. Notice, is sufficient evidence to reject the null hypothesis that the treatment and incidence of depression are independent. So I reject that claim that they are independent. You guys got that? Clear. I have evidence. I can also say that I have evidence to support the claim that they are dependent. That's also just fine. Okay? But I'm just going to say that I'm going to reject the claim that they're independent. That means that they are dependent. And in fact, what that means is there is evidence to support that there is an association between the two. To support an association. State that I'm a bit of a stickler for this. You must state your variables. Those are your variables, treatment and incidence of depression. You must state your variables everywhere inside of your null and alternative hypothesis and inside of your conclusion. Because otherwise I don't have any idea what you're talking about. Well, association between what? I have no idea whether or not you actually know what you're talking about. Not only that, if you're communicating to me about an association or about independence or dependence, I'm always going to want to know between what variables, right? You don't want to keep people guessing. So you must put in what the variables are, or I'm going to mark off points, just so that you kind of know that's the case. Always put down your information about your variables. Okay, great. So now that that's stated, according to the data, is it the case that certain activities are better for depression than others? Which activities seem to be most effective at treating depression? Well, the answer is yes. Because I rejected the null hypothesis and found that the two variables were in fact dependent, that tells me that one of the treatments is better or more effective, or categorically it could be in fact that they are less effective than the others at treating depression. But in fact, in this case, it's one is much more effective than others, and that's running on a regular basis. And you can see that because we have 82.93% of those responding or given the treatment were not depressed, which is much higher than the not depressed group in the other categories. Conversely, you could actually go over here to the depressed category and say, well, there's a much smaller incidence of depression for the running group than all the other groups. Okay, and that in fact tells me, right, that there is a statistically that in fact tells me that the running is the most effective. And so that's what I'm going to write. Running is the most effective. Because it has the lowest incidence of depression post-treatment. All right. So that concludes it. All right. So we'll go in here. We'll say, okay, I want to determine whether or not a treatment was effective in treating depression. Okay. I have two categorical variables, right? This treatment here and the incidence of depression. When I'm comparing two categorical variables, I'm using chi-squared. And that's the deal. Okay. That's the big thing here is I'm using chi-squared. And from that, everything else follows. Okay. Everything else follows. This concludes the video.